Have you ever stopped to think that the language you're speaking right now, like the very words forming in your head as you listen to my voice, might secretly be controlling what you are actually capable of thinking?
It's a pretty heavy concept to start with, right?
Right. I mean, just sit with that for a second. Most of the time, we treat language like it's a perfectly clear pane of glass.
Exactly, just a transparent medium.
Yeah, we just use it to look at the world. We see a tree, we call it a tree. We feel angry, we say we're angry.
We assume we're just slapping labels on a reality that already exists out there.
Exactly. But what if that glass isn't clear at all? What if it's deeply tinted?
Or what if it's functioning more like this hidden architecture that dictates the actual boundaries of your imagination?
Yes. And that is exactly what we are getting into today. Welcome to today's deep dive. We are exploring a truly wild, radical proposal that challenges basically everything we assume about how humans communicate.
It really does. It's a massive paradigm shift.
So we're pulling from this incredibly detailed article from Podcaster Capital. It's dated May 14th, 2026, and it's titled Worldview Embedded in Language.
And this piece goes deep into a concept called Esperanto 2.0.
Right, and let me be clear right out of the gate. This is not just about inventing a fun new way to say hello on vacation.
No, not at all.
The premise here is the intentional engineering of a planetary communication system, one assisted by artificial intelligence, specifically designed to, upgrade human consciousness.
Which is just a massive concept to wrap your head around.
Oh, totally. Okay, let's unpack this.
Yeah.
Because it challenges our default assumption that language is just this passive tool.
Right. The fundamental assertion we're exploring today is that human civilization has never been shaped solely by its technology or, its economics.
It's shaped by its vocabulary and its grammar.
Exactly. Every single language carries these hidden, baked-in assumptions.
So when you speak English or Mandarin or Arabic, you're implicitly agreeing to a specific historical framework, right?
Yes. A framework regarding time, identity, hierarchy, human cooperation, even how humanity relates to the natural world.
Wow.
The words a society invents, the sentence structures it normalizes, the concepts it chooses to just leave unnamed, all these elements quietly and continuously map out how people think.
And historically, whenever humanity has faced a foundational, earth-shattering shift in civilization, our communication systems haven't just adapted a little bit, have they?
No, they have completely transformed.
Right. And that historical context is where we really have to start. Because to figure out if we can actually build a new language today, we have to look at how we got the ones we have.
Exactly. Civilization shifts always reshape communication. Think about the agricultural revolution.
Okay, so going way back.
Right. Before that, humanity consisted of hunter-gatherers. We were nomadic. Our communication was likely intensely focused on immediate physical realities.
Like the weather, the hunt, stuff like that.
Yeah, the immediate social dynamics of a small tribe of maybe 50 to 100 people. You didn't need to talk about what was going to happen 5 years from now on a piece of land 50 miles away.
Because it didn't matter.
Exactly. But then, agriculture happens. We plant seeds. We stay in one place.
And suddenly, for the first time in human history, you have surplus grain.
You have property lines. You have debt.
Oh, wow. Debt.
Right. And a traditional tribal language, which evolved perfectly for a shared immediate environment, simply does not have the structural capacity to handle the abstract concept of a ledger.
That makes so much sense. You can't manage a multi-year grain surplus across thousands of citizens using only spoken words.
Because they just vanish into the air the moment they're uttered.
Right.
The transition to agriculture required a fundamental shift in human coordination. So, out of sheer, undeniable necessity, we invented writing.
We invented accounting.
Yes, and we created early legal language to dictate who owned what portion of the harvest.
It wasn't that people just suddenly felt like being creative.
Not at all. The new economic reality forced the language to evolve into a physical, recorded medium. Writing was born as a technology of administration.
That just blows my mind. The alphabet basically started as an Excel spreadsheet for wheat.
That is a great way to put it, honestly.
And you see this exact same dynamic play out again thousands of years later with the Industrial Revolution.
Absolutely, you do.
Before factories, you had massive populations living in rural villages speaking localized dialects. If you lived in a village in northern England, you might barely understand someone from a village 100 miles south.
And for an agricultural life, that was perfectly fine.
But then you build sprawling, mechanized factory systems. You build railways.
Precisely. You cannot run a synchronized national railway network or a complex mechanized factory using a patchwork of highly variable local dialects.
Right, you'd have train crashes every day.
Exactly. The Industrial Revolution mandated standardized communication. You needed a worker in Manchester to be able to read a technical manual written by an engineer in London.
Which created entirely new technical vocabularies that had never existed before.
It birthed the concept of mandatory standardized education and mass literacy.
Because the economic engine of industrialization required the linguistic infrastructure to match its scale.
The language had to become standardized, precise, and widely distributed.
And then we hit the shift that you and I have actually lived through.
The internet era.
Yes, which completely exploded everything we thought we knew about communication. We went from writing formal, multi-paragraph letters to communicating in this hyper-compressed, bizarrely layered digital shorthand.
We created emojis.
We created memes. Think about how much cultural context is packed into a single meme image.
It's staggering, really.
You can send someone a tiny pixelated picture of a dog
and instantly convey a massive, complex emotion regarding systemic collapse and ironic detachment.
Exactly. We developed a hybrid multimedia language because the speed of the internet demanded it.
But here is the friction we are hitting today. The tools we built for the internet era and the languages we inherited from the industrial era are suddenly looking completely inadequate for what is coming next.
That friction is exactly what the proposal for an Esperanto 2.0 is trying to address, isn't it?
Yes. We are hurtling into a phase of civilization defined by deep artificial intelligence integration, unprecedented climate migration, and total planetary interdependence.
Yet we are trying to manage these planetary scale crises using linguistic tools that were forged in the fires of regional trade and competitive nation states.
Our current languages are optimized for us versus them dynamics.
Right, for local commerce and for historical, localized cultures.
They are absolutely not optimized for planetary coordination, instant machine translation, or the kind of high-density, low-ambiguity communication required to collaborate alongside artificial intelligence on global ecological survival.
I was trying to think of a way to visualize this. Imagine the language you speak is the OS on your smartphone.
The vocabulary to describe these massive interconnected systems barely exists.
And the structural framing of our sentences is too adversarial, and the code itself is full of historical bugs and biases.
It is a very apt analogy. The legacy software is failing under modern loads, which leads directly to the monumental challenge we are dissecting today.
Right, the big question.
If our current linguistic operating system is crashing, and we fundamentally need a new one to survive the next century, how difficult is it to actually build a new language from scratch?
I mean, it sounds impossible.
To understand the sheer scale of that task, we can look at the closest parallel human beings have.
Which is what?
The creation of software programming languages.
Oh, interesting.
The process of designing a language for computers teaches us volumes about the difficulty of designing one for humans.
Because it's a closed system we actually build.
Exactly. It is arguably one of the most ambitious engineering projects a group of people can undertake, and the difficulty scales exponentially depending on what exactly you're trying to accomplish.
Right, and I found the breakdown of this in the article incredibly illuminating. It separates the difficulty of building a language into three distinct tiers.
Let's walk through them.
So the first tier is what you might call a tiny experimental language, and honestly, this surprised me. You can apparently build a functioning, simple programming language in just a few weeks or months.
You really can. A single, motivated developer working in their garage could whip one up using Python or C.
It would have basic variables, some math functions, maybe a loop or an ISO statement.
You can make it print text to a screen. It is surprising to a lot of people, but the foundational mechanics of how a computer parses logic are actually very well understood at this point.
So what does it take to build that basic language?
You need a few core components. First, you need what engineers call a lexer. In the simplest terms, a lexer acts like a reader. It takes the raw text you type and chops it up into recognizable chunks or tokens.
So it identifies what is a number, what is a word, what is a mathematical symbol.
Exactly. Next, you need a parser.
And what does a parser do?
The parser takes those chopped up tokens and figures out the grammar. It checks to ensure the syntax makes logical sense according to the rules you invented.
Much like diagramming a sentence.
Very similar.
Yeah.
The parser takes that grammar and builds an abstract syntax tree, which is essentially a visual blueprint of the logic.
Okay, I follow that.
Finally, you have an interpreter or a compiler that takes that blueprint and translates it into the raw binary instructions the computer hardware actually understands.
So as a technical exercise, this is a solved problem.
Completely. Many computer science students build one as a midterm project.
Okay, so making a tiny language that works in a vacuum is relatively easy, but then you step up to tier 2.
The practical language.
And this is where it stops being a fun weekend garage project and becomes something punishingly difficult.
Because if you want other human beings to actually use your language to build real things, like a website or an app, you suddenly have to deal with the messy reality of users making mistakes.
Right. You need error handling. If someone types the wrong thing, the language can't just silently crash.
It has to explain what went wrong. You need to build a system for modules so people can share pieces of code with each other.
And the technical demands skyrocket.
They do. You have to figure out memory management. Moving from a toy language to a practical, usable language takes years of constant iteration by a dedicated, highly skilled team.
And yet, that is still only the middle tier.
Right.
Because the third level is the major ecosystem language.
Right.
We are talking about the giants that run the modern world. Things like Go, Swift, Kotlin, or TypeScript.
The leap from tier 2 to tier 3 is staggering because these are no longer just languages. They are sprawling global cities of code.
To build something at this scale, you need package managers that allow millions of developers to securely download and update billions of lines of shared code.
You need incredibly advanced compilers that optimize the code to run lightning fast on different types of microchips.
You need deep integration into the actual text editors and software environments that developers use every day.
Building a major ecosystem language is the work of decades.
Decades?
Yes. It requires the financial backing of massive tech corporations or the coordinated effort of gigantic, highly organized open source communities.
You need specialized compiler engineers, security experts, language designers,
and people who do nothing but write technical documentation all day long.
But here is the critical pivot point in this analysis.
The social side.
Yes. The technical difficulty of building the language is entirely eclipsed by the social difficulty of getting anyone to actually use it.
This is so important.
I want everyone listening to think about their own field of work for a second, whatever it is. Think about the software, the tools, or the platforms you are forced to use every day.
Right. Think about what you actually like using.
Why do some tools win out and become the absolute industry standard, while others, which might actually be better on paper, completely disappear?
It is almost never because the winning tool is technically flawless.
Often the most technically perfect tools fail miserably.
This is the crux of ecosystem adoption. A language, whether for a computer or a human, only survives if the community actually embraces it.
Developers have to enjoy the experience of using it.
Exactly. A technically brilliant programming language will die in obscurity if it lacks strong documentation, if it doesn't have a wealth of pre-existing libraries to draw from, or if the community around it is toxic and unhelpful.
Designing the syntax, like deciding where the parentheses go, is the easiest part.
Designing a language for long-term consistency, readability, and scalability across millions of users is staggeringly difficult.
Small, seemingly minor philosophical decisions made on day one create massive, unchangeable consequences 10 years down the line.
And the reality is the users don't care about the back end. They don't care about how elegant your parser is or how sophisticated your memory management is.
Right. If you tell an average developer, hey, we use this incredibly complex concept called garbage collection, which means the language automatically cleans up obsolete digital memory so your computer doesn't freeze.
They just nod and say, great, but does the autocomplete work fast? Does it feel good to type?
Exactly. We have tools today that make the low-level technical work much easier than it was 20 years ago. But it all boils down to philosophy.
Why should this language exist? What specific problem in the world does it solve?
Does it prioritize extreme safety, like Rust?
Language design is this beautifully complex intersection of strict logic, human psychology, user experience, and underlying philosophy.
And this perfectly bridges us from the realm of computer code back to human spoken communication.
It really does.
Because we actually have a profound real-world historical precedent for a single person attempting to engineer a global human language from scratch, driven by a highly specific philosophy.
We do. And if we want to understand the feasibility, the risks, and the potential of building an Esperanto 2.0 today, we have to look deeply at the lessons of Esperanto 1.0.
I find the history of Esperanto absolutely fascinating, mostly because it completely flips the normal rules of linguistics upside down.
Oh, entirely.
Normally, human languages evolve organically, almost like biological organisms. They change gradually over thousands of years, shaped by migrations, trade routes, wars, and cultural blending.
They have completely murky origins.
Right. Nobody sat down and invented English. But Esperanto is different. It didn't evolve organically. It was intentionally engineered by one single person.
An eye doctor named L.L. Zamenhof, working in the late 19th century.
From an academic and linguistic perspective, the historical uniqueness of Esperanto cannot be overstated.
It is a marvel because we can actually observe its birth in real time.
Unlike natural languages, Esperanto has a known creator.
We know his exact design philosophy. We have his preserved drafts, his early grammar rules, the foundational texts he translated, and meticulous records of how the language began to spread internationally.
We can study exactly how this artificially planned system moved from a textbook into the minds of real people.
How communities adapted it, and how the vocabulary evolved outward from a fixed, designed starting point. It is literally a laboratory experiment in human communication playing out over a century.
And Zamenhof didn't just invent random sci-fi sounds out of thin air either. He was incredibly methodical.
Very much so.
He essentially engineered a system using the most recognizable pieces of existing European languages.
He took a huge amount of Romance vocabulary words that sound somewhat familiar if you know French, Spanish, or Italian.
He blended in Germanic influences and Slavic phonetic structures.
And then he bolted all of these familiar pieces together using a grammar system that was ruthlessly, brilliantly regular.
If you look at it, it's almost like a computer program for speech.
That's a perfect way to describe it.
In Esperanto, every single noun in the entire language ends in the letter O. Every single adjective ends in A. Every adverb ends in E. That is it.
There are 0 irregular verbs, none.
Wait, really? None at all?
Not a single one. If you learn the rule once, it applies to every single word you will ever encounter.
For the 1880s, that level of linguistic rationalization was incredibly radical.
Oh, completely. Consider the grammatical chaos of the natural languages we speak.
Right. Think of the labyrinthine conjugations of French.
Or the staggeringly complex case systems of German.
Or the utterly nonsensical spelling and pronunciation rules of English.
Zamenhof optimized the language purely for learnability.
He wanted someone to be able to pick up a book and learn the core mechanics of the language in an afternoon.
But it is vital to understand that his goal was not merely a fun technical exercise in efficiency. Esperanto was fundamentally conceived as a political and humanistic project.
The context of where and when he was living is everything here. Zamenhof lived in Bialystok, which was then part of the Russian Empire.
It was a deeply divided, ethnically tense, highly volatile region.
You had Russians, Poles, Germans, and Jewish communities living side by side in the same city, but they fiercely distrusted each other.
And a massive part of that distrust was fueled by the fact they literally could not understand one another.
They were walled off by their linguistic loyalties.
Zamenhof looked at this explosive environment and honestly believed that if these people just had a neutral, shared language, one that didn't belong to a conquering empire, one that didn't carry centuries of historical baggage, it could fundamentally reduce nationalism.
It could foster peace. Esperanto was a linguistic engineering project, yes, but at its core, it was a social philosophy and a peace movement.
And here's where we reach a critical pivot point in understanding language design. There was a massive distinction between the programming languages we discussed earlier and human languages.
What's the main difference?
Programming languages are designed explicitly to reduce ambiguity. A computer needs exact, undeniable logic or it crashes.
Right.
But human languages operate entirely differently. Human communication must handle emotion, nuance, culture, and identity.
In fact, human language thrives on ambiguity.
Exactly. The fact that a word can mean 3 slightly different things depending on context is what allows for poetry, for humor, for diplomacy, for art.
Here's where it gets really interesting. I have to say, this is the part of the Esperanto story that I find most magical.
What's that?
You have this rigid, highly organized, artificial system built by one guy with very strict rules. But once real, messy human beings actually started speaking it to each other,
It didn't stay rigid.
it became socially alive. The unpredictable human element took over the machinery. People didn't just use it to translate textbooks. Slang started to appear.
People living in different parts of the world developed different accents while speaking Esperanto.
They wrote original poetry that took advantage of the language's specific rhythms. Jokes evolved that only made sense if you understood Esperanto grammar.
Idioms formed completely organically.
And today, incredibly, there are native speakers.
Yes.
There are families who met through international Esperanto conventions, fell in love, and raised their children speaking it as their first language at home. The language literally escaped its creator's control and became a living organism.
That specific transition from a static, designed logical system on paper to a living, evolving social phenomenon is one of the most important proofs of concept we have.
It proves definitively that humans can consciously design the foundational architecture of their communication.
And that communities will still breathe chaotic emotional life into it. It's not an either-or scenario.
But having acknowledged that incredible success, we must also address the stark reality of its limitations.
Right.
Why did Esperanto, despite being brilliant and functional, never fully achieve its goal of becoming the dominant global auxiliary language?
Well, because obviously we're having this conversation in English right now.
Yeah, the artificial neutrality of Esperanto, no matter how beautiful the philosophy behind it was, just couldn't compete against the brutal, real-world power structures that drive natural languages.
English didn't become the global default because it's an easy language to learn. It's incredibly difficult and confusing.
It dominated through sheer economic might. It dominated through the British Empire, then American geopolitical dominance, Hollywood media influence, the internet, and scientific publishing.
Furthermore, nations and cultures are deeply, profoundly attached to their own languages.
Your language is your heritage, your identity, the voice of your ancestors. People do not willingly abandon that for a mathematically perfect alternative.
The legacy of Esperanto is complex. It did not take over the world, but it profoundly influenced modern linguistics, internationalist movements, and even the ethos of early open-source internet communities.
It proved the concept was physically possible.
And this historical reality brings us to the core thesis of the modern proposal.
Right, because Esperanto 1.0 was fundamentally limited by the technology and the fractured social networks of the 19th and 20th centuries. Zamenhof was working with pen, paper, and the postal service.
But what happens to this concept today? What happens when you introduce advanced artificial intelligence, massive computational power, real-time machine translation, and a globally connected digital infrastructure?
What does an Esperanto 2.0 actually look like, and how is it built?
The proposal outlines 3 different versions, or tiers, of what a modern Esperanto 2.0 could be.
Let's break those down. The first tier is the minimal version.
This is the most conservative approach.
It's essentially a highly refined, modernized, international auxiliary language.
It would take the lessons of the past century and create a system with cleaner grammar.
Phonetics optimized so that anyone from any linguistic background could pronounce the words without extreme difficulty.
And a vocabulary that draws from a much wider global pool, not just European languages like the original did.
It would be supported by basic AI learning tools. This tier is viewed as relatively feasible to achieve.
But then the concept steps up to the advanced version.
And this is where it gets intense.
The advanced version represents a leap from amateur linguistics into deep, rigorous scientific research.
This would not just be a clean language. It would be mathematically optimized using modern cognitive science and information theory.
For example, it would be explicitly designed for high accessibility, incorporating dyslexia-aware visual and phonetic design right into its foundation.
Furthermore, this version would be optimized for speech recognition algorithms and machine translation engines from day one.
It would be engineered so that software could parse it flawlessly, ensuring true, seamless cross-cultural communication.
But the absolute peak of this concept, the version that feels like we are reading science fiction but is theoretically possible, is the civilization scale version.
This is the one that really captures the imagination.
We are talking about a fully adaptive, living language ecosystem.
It would feature AI-generated vocabulary evolution.
It would have real-time translation compatibility integrated into the very core of how the language functions.
It would include highly optimized speech synthesis, so machines could speak it with perfect emotional nuance.
It might even include multimodal communication, where physical gestures and digital symbols integrate seamlessly with the spoken word.
The organizational effort required for this is staggering. The proposal compares building this version to simultaneously building a major programming language, a massive international standards organization like the ISO, a global educational ecosystem, and a worldwide social movement, all at exactly the same time.
It is a level of complexity that is almost difficult to quantify.
To try and ground this in reality, let's look at the estimated human labor required just to build a functional prototype of a civilization-scale language.
Okay, hit me with the numbers.
We are talking about 200 to 600 hours of deep linguistic work just to design the core grammatical engine.
Wow.
Another 100 to 300 hours just to select and balance the phonetic system. Up to 1,000 hours to construct the initial vocabulary architecture, ensuring it's globally representative.
And then hundreds, if not thousands, of additional hours for rigorous linguistic testing, creating the documentation, and building the initial digital tools.
All told, a credible early-stage prototype will require roughly 2,000 to 8,000 human hours of highly specialized labor.
That represents years of dedicated, full-time work for a solo researcher.
Or many months of intense coordinated labor for a small team of experts.
But, and this is the massive game-changing but, in the whole proposal, artificial intelligence completely obliterates that traditional timeline.
AI changes the entire landscape of language creation.
Imagine having access to a massive gigawatt AI computing cluster. An AI can test the difficulty of pronouncing certain sounds, calculate ambiguity rates, measure memory retention, and analyze typing efficiency across millions of simulated users in a matter of seconds.
An AI can scan thousands of existing human languages simultaneously to find the most culturally neutral semantic overlaps.
It can identify the exact phones that are statistically easiest for the entire global population to pronounce.
Zamenhof was sitting at a desk with a stack of dictionaries.
Yeah.
An AI can process the sum total of human linguistic data instantly.
The ability to simulate the language is perhaps the most revolutionary aspect of applying AI to this problem.
It really is. An AI cluster could simulate the evolution of the language before a single human being ever speaks it aloud.
Wait, like it could see the future of the language?
Basically. It could run a simulation of a century of global communication in an afternoon, predicting exactly how and where slang might form.
It could identify the most common mistakes learners will make based specifically on their native tongues.
It could simulate dialect drift, mapping out exactly where structural ambiguities will inevitably emerge when people speak quickly or emotionally.
Furthermore, once the architecture is locked in, AI could automatically generate the entire global educational infrastructure overnight.
It could create personalized textbooks, interactive voice recognition pronunciation tutors, and instant translation dictionaries tailored for every single existing language on Earth.
It massively, drastically lowers the barrier to entry, which historically has been the hardest part of language adoption.
Absolutely.
I hear all of this, and the technological capability is mind-blowing, but I have to stop you there and play devil's advocate for a second.
Okay, let's hear it.
Wait, the text explicitly says that perfectly compiling a human language is impossible. Every choice is a trade-off.
True.
If you're listening to this right now, you might be thinking, you cannot perfectly optimize a language for humans like it's a piece of software. And you'd be right, because humans are incredibly messy.
Very messy.
You can't optimize a language for every single culture, every accent, every aesthetic preference, and every political worldview simultaneously.
No, every single design choice you make is going to be a brutal trade-off.
For example, let's say you decide to make the words really short to maximize efficiency. Great, you can speak faster, but short words often lack musicality. They lack emotional texture.
Or what if you make the grammar perfectly regular, like Zamenhof's rule, where every noun ends in O?
Yes, it is incredibly easy to learn, but to a native speaker used to the chaotic rhythm and flow of a natural language, perfectly regular grammar can feel sterile, robotic, and emotionally dead.
And if you try to make everything perfectly globally neutral, don't you run the risk of stripping away all the deep, weird cultural richness that makes human language beautiful in the first place?
Exactly. That is the ultimate linguistic dilemma.
And it is a completely valid critique. If you optimize purely for technical precision and data efficiency, you often destroy poetic ambiguity and emotional resonance.
Therefore, the project of building an Esperanto 2.0 ceases to be just a technical engineering challenge.
It becomes a deeply, profoundly philosophical one.
If we actually have the power to engineer a new language, and if we accept the premise that every linguistic choice subtly shapes how the speaker interacts with the world, we are forced to ask a very uncomfortable question.
What exactly are we optimizing for?
If we aren't just trying to make data transfer faster, what kind of human consciousness are we intentionally trying to build?
And that question takes us right into the philosophical heart of this deep dive.
The entire concept pivots on a well-known theory from cognitive science and anthropology, the idea that natural languages carry hidden assumptions that quietly influence social behavior.
The classic examples are fascinating. There are languages that strongly emphasize social hierarchy, where the grammar constantly forces you to acknowledge whether the person you are speaking to is older, younger, richer, or more formal than you.
There are languages that force grammatical gender onto inanimate objects, which studies show can subtly influence how speakers perceive those objects.
There are languages that encode the concept of time in wildly different spatial ways.
Now, to be clear, these structures don't trap you. You can still think outside of them, but they create strong cognitive tendencies.
They make certain paths of thought feel like a paved highway, and other paths feel like bushwhacking through a jungle.
Precisely. The language you speak paves neural pathways. It makes some concepts incredibly easy and frictionless to express, while making alternative ways of thinking feel clunky, unnatural, or overly wordy.
So if a team were to design a civilization-scale Esperanto 2.0 today, and the ultimate goal is a massive cultural and spiritual shift to help humanity survive the next century, the design parameters change radically.
You aren't just designing for speed.
You must intentionally optimize the grammar and the vocabulary for empathy, for deep reflection, for complex cooperation, for ecological awareness, and for long-term intergenerational thinking.
The proposal actually outlines 5 specific design principles for this kind of consciousness-oriented language, and they are brilliant.
Let's go through them.
Principle 1 is reduced aggressive framing.
Many modern languages naturally encode domination, ownership, adversarial logic, and rigid binaries.
Think about how we speak every day. We talk about conquering a disease.
We talk about defeating an opponent's argument in a debate. We talk about capturing market share.
Our default metaphor for almost everything is war.
A new linguistic system could experiment with defaults that favor collaborative framing and relational expressions.
It's not about banning or censoring aggressive words. You still need to be able to express anger, but it's about making collaborative thought the grammatical default.
What if the easiest, most natural way to construct a sentence inherently implied cooperation rather than conflict?
The second principle is ecological consciousness. We touched on this earlier. But industrial civilization linguistically separates humanity, the natural world, and the economy.
We constantly use the term natural resources.
When we say resources, we are linguistically framing the entire Earth, the forests, the oceans, as merely a warehouse waiting to be exploited for human utility.
A consciousness-oriented language would intentionally merge these concepts to reinforce interdependence and complex systems thinking.
If the language inherently links human action to ecological reaction at a fundamental grammatical level, it subtly but persistently shifts how a society perceives its environment.
It becomes much harder to casually destroy an ecosystem if your language defines that ecosystem as an extension of your own community.
Let me try to paint a picture of how this might actually feel, using some of the imagery suggested in the proposal.
Okay, visualize this.
Imagine looking at a map of a glowing global digital network. But instead of the network being driven by words like profit or competition or dominance, the foundational nodes of this network are built on specific Esperanto 2.0 concepts.
Imagine a global society illuminated by a word like compreno.
Which doesn't just mean a basic understanding, but a deep, structural, empathetic comprehension of another person's reality.
Or the word collaboro, meaning genuine, synergistic collaboration without hierarchy.
Or a singular, beautifully constructed word for diurapova estanteco, encompassing the entire concept of a sustainable intergenerational future.
If these concepts are the foundational pillars of your everyday vocabulary, it is almost impossible for your worldview not to shift.
That leads directly to the third principle, temporal expansion.
Modern linguistic structures, combined with our economic systems, heavily encourage short-term thinking.
We are obsessed with the immediate present next quarter's corporate profits, tomorrow's news cycle, the dopamine hit of the next social media notification.
A new language could theoretically strengthen future-oriented reasoning.
It could build grammatical structures that actually demand intergenerational awareness.
How a society perceives its responsibility to the future is deeply intertwined with how its language constructs past, present, and future tenses.
What if expressing an action in the present tense required you to grammatically acknowledge its impact on the future?
I love that idea.
And that brings us to the fourth principle, which is the one I find most personally relatable, emotional precision.
This one is huge.
Have you ever felt a profound, complex emotion that you simply couldn't name? You try to explain to a friend why you are feeling off or why a certain event moved you to tears, but the words feel incredibly clumsy and inadequate.
You end up saying, I feel weird, or it's just heavy.
Anthropologists have noted that certain cultures have highly specific words for unique emotional states, like a specific type of grief, or the unique communal joy of working together, or the German concept of Schadenfreude.
Imagine if Esperanto 2.0 intentionally expanded our emotional literacy.
Imagine having a precise, universally understood word for the specific anxiety caused by watching ecological degradation.
Or a single word for the deep, quiet joy of knowing you are part of a functional community.
Having the exact word validates the feeling. It allows you to process it.
It would revolutionize therapy and conflict resolution, because we would finally have the tools to tell each other exactly what is happening inside our heads.
The final principle, the fifth one, is perhaps the most crucial for our current digital age: lower manipulation potential.
Our modern media ecosystems, driven by algorithms, thrive on exploiting linguistic ambiguity, emotional triggering, and tribal framing.
Misinformation spreads like wildfire, largely because natural languages allow for the extreme compression of highly complex, nuanced issues into weaponized, polarizing slogans.
The proposal theoretically suggests designing linguistic structures that inherently require context.
Imagine a grammar that visually or structurally reveals uncertainty, forcing the speaker to clearly distinguish between verified evidence and mere speculation or opinion.
While this would be extraordinarily difficult to engineer without making the language overly cumbersome, creating a communication system that is naturally resilient to algorithmic manipulation and bad faith framing is vital if a digital civilization is to survive.
Okay, so we have these massive, lofty philosophical goals: empathy, ecological awareness, resistance to algorithmic manipulation.
It sounds beautiful on paper.
But practically speaking, mechanically, how on earth does a planetary language function in the real world without just steamrolling and erasing all the beautiful, chaotic, diverse natural languages we already have?
Because if you are listening to this, you probably don't want to live in a monochrome linguistic world where everyone speaks the exact same engineered tongue.
That sounds awful.
That is the critical logistical hurdle, and it is a barrier that prevents most constructed languages from gaining traction.
The architecture of a true planetary protocol cannot be a monolithic replacement.
The proposal outlines a modular structure.
Instead of one rigid language that everyone is forced to speak perfectly in all situations, an Esperanto 2.0 would function much more like an internet protocol.
You would have a highly stable, universally understood core layer, the basic grammar and essential vocabulary.
Then branching off that stable core, you would have extensible modules.
You could have regional cultural layers that incorporate local idioms, or specialized technical layers specifically designed for aerospace engineering or medical research.
This modularity is explicitly designed to allow for expansion without causing cultural erasure.
And crucially, this new architecture has to bridge the massive gap between human thought and machine processing.
The concept here is called AI native semantics.
Right now, our natural languages are incredibly inefficient for machines to process.
When you ask an AI a question in English, the AI has to do a massive amount of computational work just to cut through the ambiguity, the slang, and the unspoken context.
A new language could be designed from the ground up so that AI systems can parse the meaning instantly, detect the nuance perfectly, and translate it into any other language without losing the underlying context.
But this creates a massive tension. The language must maintain what is called an emotion plus precision duality.
What's fascinating here is that programming languages optimize for cold, hard precision. Human language is optimized for messy, beautiful expression.
This new system somehow needs to do both simultaneously.
To achieve this duality, the language might require distinct modes or operational layers seamlessly integrated.
You might have a highly regulated, mathematically precise, formal mode used for writing international law, scientific papers, and direct AI instruction.
But you would also have a fluid, flexible, poetic mode, optimized for art, literature, and emotional expression.
You might even have a hyper-compressed mode for rapid data transfer in emergency situations.
Furthermore, the foundational architecture must prioritize accessibility from day one. It shouldn't be an afterthought.
The syntax and visual representation should be optimized for screen readers. It should seamlessly map onto sign languages for the deaf community, and the visual character set should be built to accommodate neurodivergent cognitive styles like dyslexia,
ensuring no segment of the population is structurally excluded.
There is also this concept of semantic compression, which I think is brilliant.
In our AI-driven era, we are absolutely drowning in data. We are constantly overwhelmed by information.
We desperately value faster understanding and lower cognitive load. A new language could theoretically optimize the amount of actual meaning conveyed per syllable spoken and the clarity per character written.
It's exactly like taking a massive folder of files on your computer and zipping it into a tiny compressed file before you email it.
You are packing massive amounts of emotional and technical data into a very small, highly efficient linguistic footprint.
But to make this entire massive concept relatable, the best analogy is looking at how the internet actually works.
The goal here is absolutely not. Everyone must learn this new language to replace English, or replace Mandarin, or replace Hindi.
That is a recipe for failure. The goal is an interoperability layer. It is essentially TCP/IP for human communication.
So what does this all mean?
Well, TCP/IP is the foundational communication protocol of the internet. It is the invisible set of rules that allows wildly different computer networks, a server farm running Linux in Tokyo, a MacBook in London, a smartphone in Brazil, to talk to each other flawlessly without losing their unique internal architectures or operating systems.
And Esperanto 2.0 would function exactly the same way for human societies.
It's a diplomacy protocol. It is an AI translation standard. It is a global coordination layer.
You would fully retain your native language. You would use English or Spanish or Swahili for your heritage, your local cultural identity, your poetry, and your daily life with your family.
But you would utilize the shared semantic layer, the Esperanto 2.0, specifically for precise global ecological and technological coordination where misunderstanding could be catastrophic.
It's literally like installing a universal translator plugin in our collective societal browser.
Exactly. You keep your personalized operating system running exactly how you like it, but you have this universal bridging software running quietly in the background whenever you need to connect to the wider world.
But as amazing and utopian as this all sounds, we have to look at the dark side. We have to look at the massive risks.
Because if you are intentionally building an architecture of human thought, what happens if that architecture gets hijacked?
Right. What if the plugin gets hijacked? The proposal does not shy away from this at all. It explicitly warns against the dystopian outcomes of this technology.
The risks are profound and, frankly, terrifying if mismanaged. If a civilization-scale language project is controlled by the wrong entities, the consequences are catastrophic.
We are looking at the risk of massive cultural homogenization, where unique worldviews are flattened into a single corporate or state-sanctioned perspective.
There is the risk of algorithmic control over human expression, where an AI dictates what concepts are acceptable to articulate.
There is the profound risk of political manipulation.
And perhaps most chillingly, the creation of a communication system explicitly designed from the ground up to be perfectly compatible with mass surveillance.
Natural languages are not merely tools for moving data. They are the repositories of human memory, ancestral heritage, and diverse worldviews.
Any attempt to centrally control them or forcefully replace them would be met with immense, entirely justified resistance.
It would be perceived correctly as a form of totalitarian ideological engineering.
If some massive tech monopoly or a single superpower government steps up and says, hey everyone, we've invented the perfect language and we know the correct consciousness humanity should have, so everyone starts speaking this.
It slides immediately into authoritarian social design. People will reject it instantly.
So the governance problem, the question of who actually gets to make the rules, who owns the dictionary, is the hardest part of this entire endeavor.
It's much harder than the technical AI engineering.
Who controls the vocabulary updates? Who gets to define what constitutes cultural neutrality? Who decides what political terminology is allowed or banned or modified?
If a single corporation owns the language, it's a dystopia.
If the language is controlled by a single nation, a singular megacorporation, or one specific political ideology, public trust will instantly collapse and the project will fail.
The only viable solution proposed for managing a planetary protocol is a radically decentralized hybrid governance model.
It must be entirely transparent, relying on open standards and democratic evolution.
The closest existing parallel is a combination of how Wikipedia is managed, how Git version control software works, and how the Internet Engineering Task Force governs web standards.
In this model, every single proposed change to the grammar, every single new vocabulary update must be trackable.
It must be openly debated by a diverse global consortium. It must be publicly archived.
This model, much like version control in software development, prevents any single entity, whether a government or a corporation, from secretly manipulating the semantic foundation of the civilization.
And beyond the politics and the governance, there is the raw human element. For any language movement to survive long term, it cannot feel sterile or strictly administrative.
It has to remain culturally porous. It has to be emotionally rich, highly participatory, and capable of surprise.
It has to allow for spontaneity and art, but there is one final, truly radical possibility that the proposal throws out at the very end, and it absolutely shattered my conception of what we are even talking about.
Let's hear it.
The first globally adopted Esperanto 2.0 might not even look, sound, or function like a traditional spoken language at all.
It is a stunning extrapolation of where our technology is heading.
The future of civilization-scale communication might be fundamentally multimodal.
We are moving toward a reality where communication is a fluid, real-time blend of spoken words, dynamic, symbolic, visual representations overlaid through augmented reality.
Context-aware AI assistants whispering translations or contextual data.
And deep semantic data transmitted directly between devices.
This new protocol would exist in a liminal space. It would not just be speech.
It would be something situated precisely between ancient human vocalizations, modern user interface design, and machine-to-machine data protocols.
It redefines the very boundary of what we consider a language to be.
It's almost unimaginable to picture how that feels to use, yet when you look at the trajectory of AI and augmented reality, it feels entirely possible.
We've covered a massive amount of ground today. We started by exploring the invisible architecture of thought, how the everyday words we use quietly dictate the boundaries of our reality.
We looked at the monumental, decades-long engineering challenge of building even a simple computer language,
and contrasted that with Zamenhof's 19th century miracle of Esperanto 1.0, and how that rigid system magically came alive when humans got a hold of it.
And we unpacked the jaw-dropping, slightly terrifying potential of an AI-fueled planetary semantic layer.
An Esperanto 2.0 designed specifically to foster a consciousness of empathy, ecological survival, and global cooperation.
The ultimate synthesis of this entire exploration is profound. Our current industrial civilization was built fundamentally upon languages of extraction, aggressive competition, and bureaucratic administration.
But if humanity is to survive the compounding, interconnected crises of ecological instability and unchecked AI integration, a sustainable future may absolutely require a completely new linguistic infrastructure.
We need a communication system explicitly designed from the ground up for systems thinking, for deep intercultural understanding, and for nonviolent cooperation.
The future of human language is inextricably linked to the future of human civilization itself.
We simply cannot build a new sustainable world using the exact same words and aggressive frameworks that fractured the old one.
I want you to pay close attention to your own internal monologue in your conversations today. When you speak, are you casually using language that builds rigid binaries?
Are you using adversarial framing without even realizing it?
Or are you using language that invites collaboration and systems thinking? Think about the invisible operating system running your thoughts right now.
It's a powerful thing to reflect on.
And I want to leave you with a provocative exercise, something to mull over on your own that builds on everything we've discussed today.
What is it?
If you had the power to invent just one brand new word today, a word that does not currently exist in your native language, a word specifically designed to help humanity solve a modern problem, or to help you feel a profound connection you've never been quite able to articulate, what would that word be?
That's a great question.
How would it sound? And how would having that word change the way you see the world tomorrow?